Let's see how we are going to evaluate the limit of this multivariable function, and we have x, y, z approaching 0, 0, 0. So if we put 0 into all the variables, we get 0 over 0, so we cannot draw any conclusion yet. What do we do though? On the bottom, we have x squared plus y squared plus z squared, so maybe we can use the spherical coordinate system. So let's have a look. X is equal to rho times sine phi times cosine theta. Y is equal to rho sine phi sine theta. And then z is equal to rho cosine phi. And lastly, x squared plus y squared plus z squared is equal to rho squared. And these are the formulas that we have to know. And yes, I do have another video going over how we can come up with these formulas, so make sure you guys go check that out. Okay, let's go ahead and give it a try. Here, x, y, and z is approaching the origin, but if you're talking about the spherical coordinates, the only way for us to get to the origin is that we make the distance, which is the rho, approaching 0. So this will be the same as taking the limit as rho approaching 0. And if you restrict rho to be just positive or non-negative, then this right here you can say is 0 plus. Okay, and then just plug in the formulas. On the top, we have x times y, so I'll just write this down for you guys real quick. Rho sine phi, cosine theta, y is rho sine phi, sine theta. And then we add rho sine phi, sine theta, and z is rho cosine phi. And then on the bottom, it's nice, it's just rho squared. So we have the limit as rho approaching 0 plus. Rho times rho is rho squared, and we also have rho squared here, so we can factor that out. And then we have just the rest, sine phi, so that's sine squared phi. Cosine theta, just keep that. And we add, okay, they are all different. So sine phi, sine theta, cosine phi, and then all over rho squared. And this is so nice, this and that cancel. And of course, when rho goes to 0, where's the rho anyway? We only have theta and phi left. So does that mean the answer is 0? In fact, I actually made a mistake when I was first doing this question on my own. I got careless a little bit. The answer is not 0. In fact, the answer does not exist, because at the end you can see that we don't have any rho's anymore. However, this expression is depending on phi and theta, because remember, even though we have rho approaching 0, but phi and theta, this can still be anything. So if you have different things, then you are going to get different value for the limit. This limit does not exist. However, to show a limit does not exist, I would still like to show you guys with two paths, and they give you different results. So let's do that. So what path are we going to use? Firstly, let's do the easy one. Let's just go to the origin along the x-axis. So let me write that down. Along the x-axis. And if we're going along the x-axis, that means y and z are both equal to 0. So I will just say y is equal to 0, so is z. That means we get the limit. Just care about x is approaching 0 now because y and z are exactly 0. And we will just plug in this into y and z. So let me set it up to make it super clear. And on the bottom we have x squared here, but 0 squared plus 0 squared. And that will be the limit as x approaching 0. Now do this inside out, right? Cancel, cancel. Here we have x times 0, which is 0 over x squared. This is the limit as x approaching 0. 0 divided by x squared is 0. So when x approaching 0 of 0, we get 0. Therefore, when we go along the x-axis, the limit in that is equal to 0. But now we have to come up with a different path. We cannot do like an easy one, like if you have the y-axis or the z-axis, you get 0 as well. So we have to do something slightly more different. Now how about let's go the diagonal. Y is equal to x. And we are just on the xy plane. There are infinitely many ways to go to the origin in the 3D world, but let's just go along y is equal to x on the xy plane. So that means here z will be 0, and then plug in. In this case, what we will do is I am going to keep the x because I'm setting y to be x. So we have this x still, but y is now x, and then plus y is now x, and z is 0, and then over x squared plus y is now x squared plus z is 0. Again, work this out carefully. This is the limit, x approaching 0. On the top is just x squared. On the bottom is x squared plus x squared. We have 2x squared. For this, you see that x squared cancel out very nicely. So that's just the limit as x approaching 0 of 1/2. Of course, the answer is just 1/2. But notice, these two limits are different, right? These two limits are different. So, because we have two different limits along two different paths, we can come up here and say this limit does not exist. And then we are done. Sometimes it's actually much harder to come up with the path that can actually make the argument work, that you end up with two different limits. I do have another video showing you guys how to do that in detail, so make sure you guys go check that out right here.